So this video is going to take you through how to use the sketch, organize, solve approach in order to approach any problem using electric forces. So when we are starting our problems with our sketch, we want to first draw and label x and y axes. So we're just starting with a general coordinate system, and then we want to draw all charges in the Cartesian coordinate system. Where they are, of course, and we want to identify the recipient charge, the charge that we are interested in studying. So we can use this with a dotted box or a label. Once we've drawn all our charges and identified the recipient, all other charges are actor charges. They will be acting upon our recipient with a force, right? They are responsible for a force, so they are actors or agents. And so then we want to draw our vector from each actor to the recipient. So for example, if we have two actor charges, this means we will have two R vectors. For our organized step, what we want to do is, right, for each actor charge, we are going to be solving the electric force that they provide. And this electric force is equal to K times the charge of the agent or actor times the charge of the recipient over R squared times R hat, this R hat being, of course, secretly the important part. For each actor charge, we need to identify a couple of things. So for each actor, we need to identify Q, the charge of the actor, and we need to identify little q, the charge of the recipient. Once we have this, our big problem is, of course, these r's. And so what we want to do is then to find r vector, which is equal to rx I hat plus ry j hat. And rx is the position of our recipient minus the position of the actor. Ry is the position in the y of the recipient minus the position in the y of the actor. Once we've found this, right, once we know rx and ry, then we can find r squared, which is equal to rx squared plus ry squared. And we can find r hat, which is equal to r vector over the magnitude of r, or rxi hat plus ryj hat over the square root of r squared. So the square root of rx squared plus ry squared. So once we do this, then we have r hat, r squared, capital Q, and little q. And right, this gives us everything that we need for each actor to solve the electric force for this. So then in our solve step, we want to calculate F electric for each actor charge. And what's nice is we want to leave this in component form. because our last step is that the net force is equal to the vector sum of each of these individual forces. So if we find each of these individual forces, then we just find, right, that the net force is the vector sum of each individual force. So if we use a right decomposed sum, then we can add all I hats together, all j hats together, making it much, much easier for ourselves. And our last steps are then to just simplify and to check our answer. So if we complete all of these sketch, organize, and solve steps, then we're able to have a consistent approach for how to find electric forces, that then we're going to use very similar approaches and build upon this for electric fields of discrete particles, electric fields of continuous particles, and so on throughout this semester.